Hello and welcome to the first session under the topic of deploying Curity Identity Server. My name is Judith Kader, and in this video I will explain some essential concepts of Curity Identity Server regarding its deployment. We will start from the beginning, from when you decided to try out Curity Identity Server and want to run it for the first time. From the very first deployment, we will continue with an overview of the different deployment architectures. I will give you a walkthrough on how Curity Identity Server was designed with flexibility and scalability in mind. We will then have a look at how to modify different parts of Curity Identity Server. At the end, we will see how Curity Identity Server features infrastructure as a code by creating a custom Docker image. To get started with Curity Identity Server, I recommend downloading and running the default Docker image from Curity. Just enter docker run and give your container a name. Add -e to set the environment variable of the admin password. Add -p to publish the port for the admin web interface. Publish also the port for the runtime endpoints, and point out the Docker image at curity.azurecr.io/curity/idsvr. Now we wait for Curity Identity Server to start. From the output, you see that Curity Identity Server loads some plugins that ship with the product. And at the end, we can see that the server is listening on the port for the admin UI. We have now successfully deployed Curity Identity Server. That was easy, right? Let's open the admin web interface. Open the web browser and enter https localhost port 6749/admin. The browser will prompt you with a warning because Curity Identity Server uses a self-signed certificate. You want to change that later on. Log in with the admin user and the credentials that you provided as part of the Docker command. Since our instance of the Curity Identity Server is completely empty, we can run the basic setup that will assist in setting up the basics such as the license, keys, data sources, and services. I'll spare you the details of the wizard. The basic setup created two profiles for us, an authentication service and token service, but they are still pretty empty as there are no authenticators and no clients. We can simply change that by importing an existing configuration. Open the web browser again and navigate to Curity's developer portal. Enter developer.curity.io to access the portal. You will have to log in if there is no active SSO session, like in my case. Click on the Downloads button to access the download section. You can download the binaries here and get even more instructions on how to get started using Docker, Kubernetes, and Helm or AWS CloudFormation. Scroll down and click on Configuration Samples to access the page for the configuration sample. Feel free to read through the description of the configuration to understand the content. At the end of the page, you find a link for the download. Click on the button and save the example configuration. Go back to the admin web interface and upload the example configuration file. I just drag and drop the file here and upload it. Then I commit the changes. I enter comment and click OK. If we look at the profiles now, we can see that there is an authenticator called HTML1. And there are also some clients, as well as predefined scopes. You will find references to this example configuration in our tutorials, so it is very convenient. Having a portable configuration that you can export at one place and import at another is an essential part of deploying Curity Identity Server. You can export all or just part of the configuration and merge different parts when importing. You can specify a configuration to load when starting the server for the first time. What we have now is a very basic setup, with one container that runs both admin and runtime services. This is very convenient for getting familiar with the product, but Curity Identity Server can do much more than so, which takes us to the next point on the agenda, the deployment architecture. The all-in-one setup, where the admin and runtime services run on the same node. You may use a local file-based database. It's practical for demos and testing, but it's not a deployment that I recommend running Curity Identity Server with. Obviously, you will use an external data source for users and tokens. When we talk about the data source, we mean a logical database. The actual deployment of the database can be quite complex. It may consist of several instances that are replicated and distributed, but that complexity is hidden from Curity Identity Server that treats the database as a simple data source. We should separate admin and runtime services logically and infrastructure-wise. Add a reverse proxy to secure the runtime services. Finally, add more runtime nodes to increase availability. We assume that you operate Curity Identity Server like any other critical system in your organization. You will integrate it with your existing log management and monitoring systems. Eventually, you will end up with a cluster where nodes are automatically added or removed depending on the load of the system and the health state of the nodes. This means that the system is carefully monitored and that there are automatic processes for decommissioning old and deploying new instances if required. You may make use of Kubernetes and Helm charts to achieve this. Curity Identity Server scales linear with a number of nodes. However, it requires the data layer to be in sync, which means that if one node writes a token to the database layer, then another node must be able to verify the same token within milliseconds from the write. Therefore, take the data layer into account when designing a cluster. This task can be challenging, especially if you operate across the globe and have to handle latencies. You may deploy Curity Identity Server on a global scale, with multiple domains in different regions with different jurisdictions and regulations. There will be numerous integrations and flows depending on the location of the user and related regulations. There are probably several clusters in place to meet the requirements. When it comes to Curity Identity Server, the deployment architecture always consists of an admin node and random nodes and the data layer. We also recommend making use of a reverse proxy for security reasons, but Curity Identity Server will work without as well. In a high availability architecture, you will set up clusters, use load balancing and replications for availability. You will have monitoring in place and utilize auto-scaling mechanisms to act upon changes, such as increased load or broken nodes. You can set up simple and complex scenarios in Curity Identity Server with one single configuration. Let's have a look at how that works. In the Curity Identity Server cluster, there are two types of nodes, an admin node and a runtime node. The admin node handles configuration requests, whereas the runtime node serves, we can say, all other requests. Every runtime node within the cluster will register at the admin node and receive updates regarding the configuration in a secure manner using the cluster key. The same key should not be used across different clusters. Although possible, it is not recommended to rotate the cluster key on the running cluster. Instead, rotate the key when upgrading Curity Identity Server to new versions. This way, every version of the cluster only communicates with nodes of the same version. Every runtime node keeps a local copy of the configuration. Thus, it will remain operable even in case the connection to the admin node breaks for some reason. Because of the local copy, it is recommended to set up a configuration secret, which will make sure that sensitive data in the configuration is secured even at rest. When creating the cluster, you simply specify the admin node and create a cluster key that will be used for securing the communication with the runtime nodes. Use the GenClust tool for creating the cluster configuration. To be able to join a cluster, the runtime node needs to start with some initial configuration. That is, it must be able to retrieve configuration from the admin node. Thus, the initial configuration contains at minimum the cluster configuration. In other words, the IP or hostname and port of the registration endpoint of the admin node, and the cluster key used for securing the connection. Also, the runtime node must be assigned a service role that defines which part of the configuration to load. It does not matter if this service role exists yet or not, as long as any was specified. The runtime node will stay idle until it receives a configuration update for its service role. To offload the traffic from the admin node during the act of adding a new runtime node, you can also initialize the new node with a complete configuration instead of fetching all configuration from the admin node. As I said, you have to specify the service role when joining a node to the cluster. We also recommend giving it a name so that it can be easily identified in the UI. Add the noadmin parameter to indicate that the node is a runtime node. A service role in Curity Identity Server specifies which endpoints to expose. As a result, the nodes in the same cluster may expose different endpoints and form an asymmetric cluster. What endpoints there are and their intended use is defined in profiles. Let's assume Curity Identity Server was configured with two service roles, one for internal tokens and one for public tokens. When a new node joins the cluster, it will retrieve the configuration for its service role. The internal nodes serve endpoints that issue and handle internal tokens, and the external nodes are internet-facing. With the help of profiles and service roles, you can segment the cluster and separate sensitive parts from others with one and the same configuration. The configuration or part of it can be exported as XML using the admin UI, command line interface, or RESTconf API. You can use placeholders in the XML file to parameterize the configuration. We recommend specifying a configuration encryption key for encrypting sensitive parts of the configuration. You may make use of a version control system for storing the configuration, tracing changes, and deploying certain versions. When working with the configuration XML form, the same file can be reused between different environments. By parameterizing parts of the configuration, values such as URLs and hostnames change between environments. They are therefore good candidates for being replaced by parameters, but any value in the XML can be replaced. Curity Identity Server will search for placeholders in the list of environment variables. Parameterized configuration ensures that one and the same configuration gets tested and deployed. You simply put the parameterized configuration file in the etc init folder, and Curity Identity Server will load the configuration during the first startup. In case where a configuration file is not enough, not suitable, the command line interface or the RESTconf API can be used for scripting and automating configuration tasks. In this case, the scripts can be put under version control and may run as part of a continuous integration and continuous delivery pipeline. In this example, we use the command line interface for backing up the configuration. Just create a file with the instructions and load it with the id shell command. I open the shell in my IDSVR container using the docker execute command. Let's check that there are no backups yet. The backup folder is empty. I have a backup script under user bin. It shows the configuration, exports it as XML, and saves the file in the backup folder. I load the script with the idsh command. And if I check the backup folder now, I can see that the script created a backup of my configuration. Although configuration is central in Curity Identity Server, and although it is, I dare say, a mighty tool, it is not almighty. There are ways of adapting and extending Curity Identity Server that are not covered by the configuration. For example, you may extend Curity Identity Server with plugins, or make use of certain database drivers. To increase user acceptance and strengthen the business, you may create templates for a custom look and feel. All of these extensions are file-based, and the corresponding binaries or template files must be copied to the local file system of the node. Also, log settings are specified in a file that must be shared with all the nodes to ensure consistent logging and log management. In addition, you may have scripts for procedures or post-commit hooks. So there are plugins, drivers, templates, log settings, and scripts on the local file system to keep track of. Here is a list of files relative to the installation folder of Curity Identity Server. Please do not consider it complete. Let's have a look how we can utilize these cool features during a deployment. We will create a custom Docker image based on Curity's default image. We have a parameterized configuration that we will copy to our image. We will also put the license in the image. We have the backup script that we will copy to the post-commit scripts folder. There is even another script called first run that will run when the server starts for the first time. We will also add a database driver for the external data source to our custom image. And we will create the folder for our backups that we declare as a volume. During deployment, we simply specify the environment variables to fill the placeholders with. We will also add the production-specific keys and certificates by mounting the file prod.crypto.xml in the container. And we will map a volume to persist the backups. We want to deploy an admin node, and we will make use of a configuration encryption key. Let's see how it all works together. We build our custom image from the Docker file. Then we run a container from the custom image. I copied the command, it was too long for typing. I also spare you the output and jump right to the end, where the server is up and running. So, what did we deploy? In the Facilities menu, we can see the production keys. When I open the settings for the default database, we can see that it points to my data source server. We also want to know if our backup works. To prove I'm not cheating, I show you that there are no backups yet, neither in the container nor locally. I use docker execute command to list the files in the backup folder of the container. There are no files. And my local backup folder? There are no files here either. Now I just generate a new secret for some client and I commit the changes. I call it test backup. I open the terminal again and check if a backup file was created. I use the docker execute command to list the files in the backup folder of the container. I can see that there is a backup file now. Because we used the volume, it should also be available in my local backup folder, which it is. We have learned that configuration Curity Identity Server is portable. You can export and import the configuration or part of it different instances. You can also parameterize and encrypt the configuration. The configuration XML file can be put under version control and serve as backup. We have heard that Curity Identity Server has two interfaces for scripting: the command line interface and RESTconf API. And we have seen how to back up the configuration using the CLI. We have also learned that the cluster in Curity Identity Server consists of an admin node for managing the configuration and independent runtime nodes. We now know that there is a cluster key that protects the communication between the admin node and runtime nodes. And we know that the runtime nodes keep serving requests even if the admin node goes down. These were the essentials of Curity Identity Server regarding its deployment. Feel free to contact us over any of the contact options listed here if you have any questions or comments. Thank you for listening.